Fudan's University's researchers have devised a way to reduce memory requirements when fine tuning LLMs. These researchers, as you can see on your screen, and I'm sorry I cannot pronounce their name properly, so I will just leave it as is. They have come up with a modification of stochastic gradient descent that stores less data than other optimizers during the fine tuning. In this paper, which is quite a fine read here on a very nice Friday morning, and I can assure you it's very nicely written. This shares this research where optimizers require a lot of memory to store an entire network's worth of parameters, gradients, activations, and optimizer states. While Adam has overtaken stochastic gradient descent or SGD for training, SGD remains a popular choice for fine tuning partly because it requires less memory. Nonetheless, SGD must store an entire network's gradient, which with state of the art models can amount to tens or hundreds of gigabytes before it updates the network all at once. Updating the network layer by layer requires storing only one layer's gradient, a more memory efficient twist on typical SGD. The way it works is quite interesting. The researchers have fine-tuned Llama on 6 datasets in SuperGLUE, and SuperGLUE is a benchmark for language understanding and reasoning that includes tasks such as answering MCQs or multiple choice questions. Now, authors have modified SGD to compute gradient for one layer and update that layer weights before advancing to the next. In their various tests, the results are astounding. LOMO required less memory than popular optimizers and achieved better performance than the popular memory efficient fine tuning technique LoRa. The researchers fine tuned separate instances of Llama 7 billion using LOMO and two popular optimizers SGD and ADAMW. ADAMW is a modified version of ADAM. They required 14.6 GB, 52.0 GB, and 102.2 GB of memory respectively. So you can see that LOMO's memory requirement was only 14 GB, whereas ADAMW's requirement was 102 GB. So the difference is huge. As I was saying, the results are astounding, and you can even see on your screen too. They all required the same amount of memory to store model parameter, by the way, which was around 12.15 GB, and activations were 1.79 GB. However, when it comes to gradient, LOMO required only 0.24 GB, while SGD and ADAMW each required more than 12 GB. So it all boiled down to the gradients. The biggest difference was optimizer state memory. LOMO required nothing like 0 GB, SGD required 25 GB, and ADAM required 75 GB. So, how cool is that? Now, we have LoRa or low rank adaptation already, and they do save memory by fine tuning a small number of parameters relative to a network's total parameter count. However, because it adjusts only a small number of parameters, the performance came from fine tuning is less than it could be. So that is where I think this could be one of the best future technologies to save memory requirements. That's it. I'll drop the link to paper and video's description. Let me know your thoughts. If you like the content, please consider subscribing to the channel. And if you're already subscribed, please share it among your network. Thanks.